L'Hopital's rule. And L'Hopital's rule deals with indeterminate forms in finding limits. And remember what our process was. If I'm going to find a limit, plug it in, right? Number out, done. And then what happened? Plug it in, 0 over 0, what was the issue? What did you have to do? Algebra. This is going to take care of this guy right here. It's called an indeterminate form. It's infinity over infinity, 0 over 0, 0 times infinity. You say 0 times infinity is 0. Not necessarily. Because infinity isn't a number. If infinity were a number, you could say that's the case. But it's not a number. So it says, what do you do with these? Well, in the old days, first thing I would do, plug it in, plug it in. This would be 1 squared minus 1 over 1 minus 1, which is a 0 over 0 form. That's an indeterminate form. And then we would do some algebra, right? Mm-hmm. Which means factor. X minus 1's reduced out. Then we take the limit as x goes to 1 of x plus 1. Because remember, this is now a hole in the graph, right? And we get 2. That was our solution. With this guy, remember, we're looking at this. This would be infinity squared plus 2 times infinity minus 1 over 5 times infinity minus 1. I get infinity over infinity. But it wasn't 1. And we really didn't have a means to deal with necessarily infinity over infinity. We could say, okay, I'm going to take a look at my model. My model is x squared over 5x. This is x over 5. This goes to infinity over 5. This goes to infinity. So we say, well, it's infinity. But we didn't have a way of dealing with it other than kind of playing around with it. Then we had this guy. And if you take a look, this is e to the 0 minus 1 times 1 over 0, which is 1 minus 1, that's 0, times 1 divided by 0 is infinity. It's 1 times infinity. Don't know what to do with that. I could rewrite this as x goes to 0 of e to the x minus 1 over x. We're going to 0. This is e to the 0 minus 1 over 0. Now I've got a 0 over 0 form. So it's like, I don't know how to do that either. And especially when I'm dealing with e's. Does this have a limit or does this not have a limit? I don't know. Indeterminate forms just say, I don't know. We need to do something. Well, the something we're now going to be capable of doing is something called L'Hopital's rule. L'Hopital's rule is very straightforward. If you get a 0 over 0 form, only works for 2 forms, or infinity divided by infinity form, L'Hopital's rule says this: the limit as x approaches c of f of x divided by g of x is the same as if you take the limit as x approaches c of the derivative of f of x divided by the derivative of g of x. Weird, but true. Thank you, L'Hopital.